Back guys, in this video we're going to code the melee enemy. Alright, let's jump right into it. The first thing I'm going to do is create a new C# script that I will call melee enemy. Once it's been created, just double click on it to open it up in your text editor. Alright, so the first thing we need to do is derive from our enemy script like we discussed in the previous video. So it's super simple to do. We're just going to replace mono behavior with enemy. So now just save your script and I'm going to show you how it works inside of Unity. Alright, so now selecting your melee enemy, just remove the enemy script and we're going to replace it with the melee enemy script. And as you can see, even though in our melee enemy script we've got 0 lines of code, we have still access to the health variable. So we fill it in and press the play button, you'll see that it acts exactly as we did in the previous video. Alright, so now all we have to do is fill in our melee enemy script and maybe the enemy script as well to code the specific functionality that we want for our melee enemy. Alright, let's do that right now. First thing we need is a reference to the player. So all our enemies are going to need a reference to the player, so we're going to add that inside of our general enemy script. We need to make it public because otherwise the variable will not be accessible inside of the melee enemy script, but we don't want it to show up inside of the Unity inspector. To do so, we're just going to make the public transform variable called player, but we're going to add at the top of it the hide inspector line right here. So this will make it public so that our melee enemy script can access it, but it will not show up inside of the Unity inspector. And so after, we're just going to make the void start function, and we're going to set player equal to GameObject.find GameObject with tag. We're going to give it the tag player, and then we're just going to say .transform to get the transform component on the player object. Okay, so basically our player variable will be equal to the game object that has the tag of player attached to it. So we have to add the player tag to our player right now. Inside of Unity, I've got my player selected. I'm just going to go under tag and add the player tag. It should be already there because it is a default Unity tag. Inside of my melee enemy specific script, the first thing we want is the melee enemy to follow the player around. So for that, I'm going to start off by creating a public float variable called stop distance. Our melee enemy will be chasing the player until he reaches a distance of stop distance to the player. So inside of my void update function, I'm first going to check if the player is not equal to null, just to make sure that he is not dead. So I'm just going to say if player is not equal to null, then we can run the code. So remember guys, we don't have any player variable in this script, so this player variable here is actually the player variable from our general enemy script, which is right here. If the player is not equal to null, I'm going to check if the vector2 distance between my current position, so transform.position, and the player.position is greater than the stop distance. So in other words, if we are still too far away from the player. So if we are too far away from the player, we want to continue to move towards the player. To do so, we're going to say transform.position is equal to vector2.moveTowards. So vector2.moveTowards acts similar as the vector2.lurk function that we saw in previous videos. We first need to pass in our current position, so that's just transform.position. Then we have to pass in our target position, so that would be the player.position, and then we have to pass in a speed. So inside of my enemy script, I'm going to add a public float variable called speed, because all our enemies will be needing a speed variable later on. Okay, so save that, and now inside of my melee enemy script, I will just say the speed is equal to the speed variable multiplied with time.delta time, to make it frame rate independent as usual. If we now save our script, we could go and test this out inside of Unity. For the speed value, I'm going to choose something like 20, and for the stop distance, I will choose 10. So if we now press the play button, you'll see that the enemy is successfully following the player around, and once it reaches a stop distance, it stops right there. Next step is to give our melee enemy the ability to leap towards the player to deal damage to him. Let's do that right now. First thing we need to do is to make a timer just like we did for our weapon script. We don't want our enemy to be able to attack every single frame, so we want to make a time between attacks variable. So we're going to add that variable inside of the general enemy script because all our enemies will be attacking, and so all of them will need to have a time between attacks variable. So right underneath my speed variable, I'm going to create a public float time between attacks. So then inside of my melee enemy script, we need to create that private float attack time variable that will store the exact time when we could launch our next attack. If the player is not equal to null, then we're checking if the distance is greater than stop distance. And right after that, we're going to say else, which means that if we are in here, we have reached the stop distance. That means we're near enough to the player to launch our attack. So if we are near enough, we're going to check if the current time in the game, so time.time, is greater or equal than our attack time. If it is, then we're going to want to attack, and then we're going to want to set the attack time back equal to the current time in the game, so time.time, and we're going to add our time between attacks variable from our enemy script. Alright, so now for the attack itself, we're not going to just deal damage to the player because we want to animate our melee enemy to move very fastly towards the player and then move back to his original position. And we can't just call a simple function to that because a function gets called in one single frame. And we don't want the animation to last just one single frame, otherwise we won't be able to see it. So to call a function over a certain period of time, we use something called a coroutine. Alright, so underneath my update function, I'm going to create a coroutine by saying iEnumerator, and I'm going to call it attack. So the structure is exactly like a function, but instead of using the void keyword, I'm using this weird iEnumerator keyword. Right, so now to call the attack coroutine, all we have to do is say start coroutine, and then pass in the name of our coroutine, which is attack. Okay, now all we have to do is fill in our attack coroutine and we will be good to go. Very first thing we want to do is to deal the damage to the player. To do so, first we need to have a function on the player script that can handle taking damage. So for that, I'm going to go inside the enemy script. I'm just going to copy the take damage function and I'm going to paste it inside of the player script because it is exactly the same. All we have to do is come up here and add a public float health variable and then we're good to go. Let's save that. And now inside of my attack coroutine, I'm going to say player.getComponent player to get the player script. And then I'm going to call the take damage function. And then we need to have a damage amount. So for that, I'm going to go back inside of the enemy script and I'm going to add a public int damage variable because all enemies will need to have a damage variable. I'll save that. Inside of my melee enemy script, I will add the damage variable as my argument. Right, so now we have to animate our enemy to leap towards the player and then move back to his original position. First thing we need is to create two variables, a target position and a original position. So the vector2 original position will be equal simply to our current position, so that's transform.position. So this is the position of the melee enemy before he leaps towards the player. And then we're going to create a vector2 target position that is going to be equal to the position of the player before he leaps, so that's player.position. Next off, I'm going to create a float variable called %. I'm going to set it equal to 0. So this variable here will store how much have we done of the animation so far. So when it's at 0, it means that we have just started our animation, and when it's at 1, it would mean that we have completed the animation. After that, we are going to run a certain piece of code while the % variable is less or equal to 1. First of all, we need to increment the % variable by the time.deltaTime variable. So time.deltaTime acts like a counter. So every frame it'll be adding a little bit to the % variable so that it reaches 1. And we want that to be a little bit faster than the default time.deltaTime. So we're just going to come up here and create a public float variable called attack speed. And we're simply going to multiply time.deltaTime with our attack speed variable. So don't worry if you don't understand all this code, it is quite complex, but you just have to understand that this variable will enable us to perform the animation of going towards the target position and then coming back to the original position based on the percent variable. All we have to do now is say transform.position and set it equal to our famous vector2.lerp function. First parameter we need to pass in is our original position. We want to move towards our target position, and we want to do that based on our formula variable that we calculated right above. The very last line of code that we have to say is yield return null. And this lets us run the animation over a period of time because it's going to skip to the next frame instead of just finishing the function at the very first frame. So that's the power of IE enumerators. It's thanks to this small little line here, yield return null. Okay, so now if you save your script, we'll be able to test this inside of Unity. Alright, so for the variables, I decided for the timer 2 attacks to set it to 3, damage 1, the stop distance I kept it at 10, and for the attack speed I chose 8. So you could use my values or you could test it out on your own, and that's what we recommend. You play test and try to find the values that you like for the game that you are making. For the player, we decided to give him a health of 5. Right, so now we can press the play button and test this out. So as you can see, the enemy is following the player, and once he reaches a certain distance, every 3 seconds he will leap towards the player and deal damage to him, and once he has done that 5 times, the player should destroy himself, and that's how we see it right there. Perfect. And once the player is dead, the enemy is not leaping towards the player anymore, because remember, we added the safety measure checking if the player is not equal to null. There's one little problem, is that when the enemy leaps towards the player is moving, and that's because the player and the enemy are colliding with each other, and we do not want that. So to fix that, we're just going to come up to edit, project settings, and we're going to go to physics 2D. And basically here we've got this table of all the layers in our game, and we could check or uncheck if we want collisions between them. So we have to create the player and the enemy layer. So I'm just going to select the player, go under the layer tab, I'm going to say add layer. I'm going to add the player and the enemy layer. Now select the player and I will choose the player layer. I'm going to say yes, change children. I'm going to select the melee enemy, choose the enemy layer, and I'll say yes, change children. Now edit, project settings, physics 2D. We could choose the enemy and player intersection and uncheck the box. So now if we press play, you'll see that the enemy is attacking the player and the player is not moving. That's awesome, and that's what we wanted. Alright, great work guys, and I'll see